Okay, good morning. Only Ali is here, right? So
Yes, sir.
let's
I'm here.
yeah, no problem, no problem. So let's wait for more 2 minutes. All right, maybe some more people come in. Meanwhile, please open the R Studio and Blackboard. So let me see. All right, so today I'm gonna talk about the module two. All right, module two. So we still have the last part of the lab two in the module two. All right, and assignment one should be due yesterday night. All right, so if anybody has not submitted, please as soon as possible. I think I give you most of 2 days delay, most like 2 days, and but with some discount. All right. Um, the and then I also upload the modules three. All right, module three. I'm gonna talk about the for today a little bit part and some of for the next week. All right, so this is module three, probably our most recent 1 or 2 weeks, the workload here on here. And meanwhile, definitely you need to review by your own self, right? And we have mentioned last class, may or may not. Let me see. Course contains. Um, yeah, I think I have put the textbook here. Okay, so this is the textbook we majorly use for this class, and actually all of my code from this book. This book is short, and this semester will go through that, and they also give a very good explanation in writing about what's the meaning of this line. Of course, in the class, I talk about this orally, right? What's the meaning of this? But if you just look at the code when you go back home, you probably have no idea what it's about. That you can see my video, all right, because I will explain one by one. But if you want some written, you can go to this textbook, all right. So I strictly follow this textbook order, and on the order of the lab exercise. All right, that's it. And they also will state what's the question background behind this each code. So I think it will be very helpful. All right. Um, okay, so that's all what I've talked about. And don't forget the homework. The homework has been due yesterday night, right? So if you have not submitted, please ask immediately. All right. So that's the homework issue. And I'll talk about the solution next week. All right. Okay, so let's firstly open the lab two and see what we have left in the next class. For the last class, we have not discussed yet. Let's look at the video. Look at the R Studio. Uh, and let me open the file. So two. All right, so let's firstly see what we have the last class, right? So last class we basically have discussed the you firstly store your the data I have put there in the Blackboard, and you download them, all right, along with the R files on your computer in a same folder, and you read.csv is the traditional the way you want to read into the CSV format, all right, and setwd is basically to tell the computer where all of the files stored, all right, so the computer will go to that file to find out the data. You mentioned that, right? For example, this is the now remember this file is the upper level, the upper level. And in this file, you have such .csv. All right, that's their relationship. And those are some small part of how to check the data, right? How to check them, how to calculate the sum and the mean. Table basically demonstrate the frequency and the probability for each category. And last class we also introduced what is the factor. All right, so I will not repeat there again. So and in last class we also have talked about how to recode the original binary numbers, like 0, 1 means employed, unemployed, default or financially healthy. You convert to not default or default, change the character and change the letters, because the software will understand it, since you have specified the two levels, right? 0, 1, 2 levels, labels. They will know that each label will corresponding to each factors correspondingly. All right. And be careful those grammar, right? So all the function will be in the factor, all right, in the factors. And this one basically means original data says we have employment variable. All right, you basically change the variable contains from number 1 and 0 to letter employed or not. All right. And when you use the factor, right, you want to factorize them, you need to re-mention the variable again. All right, the variable again. So to let the computer know where's the data you're mean to. All right. Okay, so and the last class, most importantly, we also introduced the tidyverse, which is probably the most powerful packages for data manipulation in the software. All right, and it's very powerful. For example, when you call this package, all right, and you work on the original data, DEF data we have established initially, all right, and for example, we only want, so for example, these 3 lines, right? I didn't write them, but you better want to write down just to talk about here. So these 3 lines operation or code means that I want to check the first 6 rows, 6 observations of 2 variables. Okay, that's what they want to do. So that means the last line is had. Had simply means demonstrate the first 6 observation, or say 6 rows. All right. Which variables? We want to select these 2 variables. And in which data? DFAT data. All right. And all of them connect by the pipe, right? Double percentage sign. So in this case, we can more concisely to express the operations. All right. Okay, and or for example, you can basically, this one here, I establish a new data, initiate new data 2, all right, because I don't want to contaminate the original raw data here in the previously in here. So data 2, basically, I want to drop 1 column. So you basically can select negative the name of the variable. You have many ways to do that. I think I previously mentioned that if you for a data frame or even matrix, you basically use negative that column order, right? For example, in this variable in the column 3, you basically negative 3. That means drop this. But this one is probably looks like much better because you directly point to the name. All right, you drop the variable name, and it's more likely more straightforward. All right, and the select. All right, so this one is original data. All right, we store the data on, and after working on this, drop this variable, I assign the new data frame update to a new name. All right, so in that case, they can separate with the raw one. All right, so and we also have a talk about the filter. All right, the filter default equals defaulted and had. So this one is simply that I only want the observations, which is a defaulted, because the reason that we understand defaulted usually only a certain percentage of all the observation. In this case, I think we have run before, right? Around, I forgot how many percent, 30% or 10%. It's a very small amount of them. So I want to look into what the characters with the specialties, with the factors impact the determinants of the default loans. So in this case, I want to get subset all the defaulted people and the data and look into the reason. So in this case, I want to use the filter. All right, filter. So filter, that means in this variable, I only want defaulted. Remember, we only two types. One is undefaulted, the other is defaulted, right? And you want to head. That this basically means you want to demonstrate the first 6 observations. All right. You want to keep this bracket here. I just want to understand. The reason is that, remember, when you use the head before, the head inside the bracket should be the data you want to present, the data name. All right, the data frame name. However, we don't need to write anything here because we already used the pipe, the operation to connect to the data at the first line. So you don't need to write again here in the bracket. All right. And by the way, actually the data is changing. For example, in the second line, we already only want the defaulted data. So it's changing, right? So in that case, you want to keep the nothing here. That simply means the most recently updated data frame after a series of manipulation. And sometimes if you use the pipe sign here, you also can summarize. There's some statistical, the property, right, for certain column variable, right, like balance of salary, right? So those are the last class we have discussed. I give you 1 minute to think about if you have any questions. I understanding those things. Okay. We will not touch Python. All right. Are you interested? If you're interested, we can discuss a little bit later on, see if I can talk about something here, because Python is a little bit hard to through the Zoom. All right. So if you mention this, let me talk about in 5 minutes to discuss the relationship between the Python and what's the functions related to the machine learning here. All right. So let me, I want to talk a little bit on that. All right. I understand, the job market is, if you're interested in this, definitely requires something. All right. And I will talk a little bit on to start up, or this for you. All right. Just talk about it a little bit. And if you're interested more, and yeah, my syllabus includes that, but the thing that we want to look into, the algorithm, the methods, right? Because this is a big building block. Either type of software is kind of this tools intermediary. So I decided to focus on using the easiest software to demonstrate the machine learning theories there, right? So that's my purpose. And let me talk about a little bit here. All right. So simply, this semester we will not introduce Python here. All right, just use the R. All right, so let me mention a little bit here the relationship since you mentioned it here. All right, I would like to say, so far we have 2 different type of the software. We have sorry, this is really bad color. So we have R here. All right, we have Python here. All right, and actually, to some extent, we probably have some others. For example, we have a well, anyways, I think that's probably the most important too. Some people use the SQL, but this software is less likely to be touched in the academic because this software is not specifically meant to finance or something. All right, so in the classroom we seldom to introduce, but they have many ways to learn that. All right, but I think this two software has been more than enough. So this two software has totally different structure. All right, it's totally different structure. I would like to say R is more straightforward. All right, if you want to solve some problem, you solve that. All right, line by line, step by step. Python is more likely object oriented. All right, all object oriented. So that means object oriented language. So what I mean by object language? So I think that so far is too it is too hard for you to understand. All right, but let me give you some simple examples here. What do you mean by object-oriented language here? Programming, or as you can say OOP, our algorithm, whatever. All right, object-oriented. So what does it mean here? For example, let's say you have a team, right? Your manager, you have a team in the big banking, and you have many products related to the interest rate. All right, let's say interest rate. All right, interest rate. We understand interest rate. This is a very big products. For example, you can forecast the interest rate. You want to look into the interest rate impact the mortgage. You want to look into the interest rate on the derivative. That's probably most important thing. All right. For example, we have a like a swaps. I'm not sure if you know that heard about this, like interest swap. We have an interest rate hedging strategies. All right, the pricing, the interest rate linked the products, right? Mortgage definitely one of the important thing, but there's other more, the derivative is very complex. So in this case, basically interest rate is our object. All right, it's object. So under this object, we have many functions, right? For example, there's interest rate. I want the plotting. That's probably the most important, most simple ways, right? We also learned the plot in R. We also interest rate. We also have a, another function. I want a derivative. All right, derivative. We also have functions. For example, another function, the interest rate. Let's say regression. All right, this is to look into the statistical in term structure, something like that. All right, regression. All right, or sometimes we want to look into term structure. Those are a little bit high level finance knowledge. You don't need to necessarily understand all of them. Term structure. All right, term structure. So my question is that you're a Python developer or users, right? So you want to talk with outsiders. Okay, some of the people who use your software, and your software will be easy to demonstrate to them because, for example, say your customer says, or your boss wants to say, I want to use the function of the interest rate related to the derivative. So in this case, you have a function. So for the R, for example, dot derivative. This is the function. All right. So you basically go into this function to do a lot of calculation. And if you want to do plotting, you can be interested to use the plot. All right, the functions. So this is all in all of the work we have talking about related to the interest rate, and all of the function can be of subjects of them. All right. And so in this case, this type of idea or algorithm is very like a tree levels and easy to be connected with outsiders. So that's why the when I use the Python is why we call them object oriented. All right, this is the one thing. And in the interest rate here, of course, we have a lot of parameters, right? But most importantly, we have interest parameters, right? We have interest we have a yield curve, we have interest rate, we have a time series. So all the parameters can be here. All right, you can put interest rate bracket. So those are parameters, and those parameters will be, of course, transmit to necessary functions, which will use either part of all of them. All right. So, right, for example, if you want to plot, definitely plot need to use the historical data. The data will be transferred to here. All right. For example, if you want to look into the, say, derivative, all right, derivative probably need to use the market information, and the information go there. So this is like a tree levels, right? Transmit to level by level. This is the big picture. So why the Python is usually the very powerful in the building the large, the database for bigger banking. For example, like I said, the Morgan Stanley, they have initiated project since 1990s to build the cores, KUARTZ cores, the project to transfer all of the derivative trading in a platform to the Python at that time. Now, the question that if the R is another things, all right. So let's. I'm not saying that it's necessarily advanced or not, but obviously it's kind of the way usually the computer science, the specialists working in these directions. Now, let's say if I want to talk about R here. Now, R we have used part of them, right? You have some feeling this. So this way is that this one is relatively easy. All right, easy. All right, easy. And it's particularly building for some single product. For example, I just simply want to plot interest rate. All right, plot interest rate. So you basically read into the interest rate and you plot them. So this you just simply single out, the project you want to do. Instead of like the Python can be integrate all of the functions into this big umbrella. All right, the subject. So the idea is a little bit different. So the Python have some specific structure, or grammars building to specifically cater to this purpose. All right, but R is not necessarily that way. Or R is more likely straightforward. Right, do what kind of project you want to do right now, and not quite friendly to integrate all of the function building under one big blocks and for the outside users, right? Something like that. So so R is more likely for academics, for example. I write a couple papers, and each paper will tackle different topics. Now, of course, R is better for me because the second paper will not use the same program in the first paper. All right, for example, some paper look into the capital investment, and the next paper I'm going to look into derivative. My next paper probably is using the international economics. So different topic will use a different idea to programming. Of course, Python is. I'm not saying Python has no. I would say Python has no advantage. It's the same as R here. All right, but if you want to building a libraries, all right, libraries, and the library, and this libraries has all of the the targeted interest rate, for example, a lot of relevant function there. You can building a whole package of that. All right. So in that case, you probably use the Python more useful for this here. All right. So that's why I like we do homework, right? We have probably like a 4 homework, and each homework will tackle different things. I don't think Python has you not necessarily use that. All right. So this is the one thing difference I just want to mention here. All right. Now let's talk about the other things. All right, so let's talk about the machine learning and deep learning. All right, in the recent years, people really hot topic in this case. Let's talk about these two software differences. I'd like to say this two software has not much very big differences, and we understand there's a very several famous deep learning basic function. There is I think there is a I'm not sure if I've heard before. One is a TensorFlow. All right, TensorFlow. The other is a Keras. All right. This is a two kind of, because if we use the deep learning, that means we basically want to simulate the human neutrons, the neurology, the science and to solve the or finance or economic problem or other social science, and you need a lot of functions which is dedicated to the deep learning or the machine learning and the functions packages, right? Developed by this two libraries. All right, these are totally independent from R, independent from Python, because TensorFlow is developed by the Google. All right, it's Google, and Keras I think developed by the Facebook or the Meta. All right, now, all right, Meta, Facebook. Okay, so so those two things are building for those kind of things calculation. All right, for example, like in the first class I mentioned, if I want to predict the time series in a currency, for example, I want to simulate the complex time series, the process, and the want to make forecasting, you better want to use some mathematical tools here. All right, and these tools has been incorporated into the we have here in R, we have here. We also have a Python. So basically, this two software has been so popular that this two library has been incorporated into that. That basically you just similar to our packages we have used so far, and like Tidyverse, right? You basically call that functions and basically introduce these things into your R environment and then use them. And it's similar for Python. So they're the same thing. So I like to say on the backbone functions, this two software has no differences. All right, that's the things. Okay, so And the next thing I want, the last thing about in this field is that talk about the natural linguistic processing. Let's talk about NLP. So those are basically belongs to introduction before, right? But I just want to mention again. So NLP, which is a natural linguistic processing. Usually people also call it computational linguistic, all right? Computational linguistics, something like that, or text mining, like the class, which I will open the next spring semester. So analyze the human language and their tone sentiments, how that impacted markets. If you look at nowadays, for example, the people were talking about the sentiments about the future inflation expectation, all right, and how does it impact the market. So we will analyze the human language in that case. So in that case, you basically need a big data, all right, the data in terms of video and message. For example, if like a Twitter message, if the video is talk about the some popular videos, so in that case, so there's a big data, and you want to analyze video, you want to analyze the people's talking like a Reddit, talk about those things, right? And you want to analyze them. So those are very, very big data. So in this case, you need to use the R or Python, goes to www, all right, goes to the website. It goes to the website, and a website there have, for example, like a Twitter account, there has a lot of comments and retweets, all right, billions and billions of every day. All right, so in this case, to visit those websites and to analyze the data, all right, the data will fit in back into R, you want to analyze them, all right, and it's similar for the Python. The only difference that here, the Python sometimes has more function in this case, all right, when connected with the website and some function to analyze very big data. Usually if you use the R, I think the CPU probably will be burning. That means it's a little bit slow, but the Python is a little bit faster. All right, so this is the other differences. And since I talked about this, let me give a, sorry, talk a little bit more on that. I want to talk about last thing, I promised last, and go back to our class. Let's talk about the, although I just kind of like a precursor to our next spring class, spring semester, if you select my course, let's talk about the text and the video, all right? What's the difference between them in terms of data? All right, we have to see this every day, right? You have YouTube, you have everything like text, you have like a word, all right, like a Twitter. So if you want to ask a question, text and video, which one is larger in terms of data size? Let's say the video about, let's say 1 minute video, 1 minute video, and text probably one book. All right, which one is larger in terms of the size? Right, so I would like to say probably the video's data size is much bigger than the book, even the 1 minute. The reason is that, let's say, what is a video? Okay, so the video usually basically a change of picture, picture 1, picture 2, picture 5. So each picture will present you, I think, 10 to negative 9 seconds. I forgot like negative 9 or negative 5, but anyways, it's all of a sudden, right? It's faster than you blink, right? So when it's faster than you blink, that means you feel that those pictures is changed, it's like a continuously flow, all right? So in this case, that's why I say even for 1 minute video, they probably have a think about the 1 minute divided by 10 to the negative, let's say not about a 9, let's 10 to the negative 5 seconds. How many pictures we have here? All right, millions of them. All right, now let's talk about picture and the text. Which one's larger? Let's talk about text and the one picture. Now, for example, let's say text, let's say 5. 5 is a number. All right, absolutely. In the computer, the size of the will occupy very, very trivial in your CPU space. It's just one number. That's it. Now let's talk about the picture 5. Let's say this is a paper, right? This is 5. You also, some people write 5 like this. Some people write like 5 like this. Some people write 5 like more crazy, all right, like this. And some people write like this for art design. Okay, there's many ways of the 5. This is a paper. Now, you wanna help the FBI to make some criminal records in the investigation, or for financial professional, you want to identify things, right? And this is very vague. And there's many ways to write a 5 here. But the question that how can you let the computer know it is a 5, not a 3 or 7? So the thing is that we need to talk about the pixel. All right, so that means the pixel, we may have this. We can discretize each picture with each cell, right? This is cell 1, cell 2, cell 3, cell 4, cell 5, something like that. We understand if you talk about the picture, you know, the precision is gonna like a 1200 times 1200. That means there's 1200 pixel here. All right. Of course, you can see the more, the smaller actually the more precision. Now the question, what's the difference between the 5 and the 3? All right, those are different files. So basically, we're talking about the probability. That means if you write a 5, I would like to say the chances that this cell will be blank will be high. Right? This is because the nature of the file. But if you talk about those pixels, the chances will be higher. There's a line across there because that's the 5 right in this way. All right. If you look those pixels here, so there will be a line across that on the diagonal. All right. So basically, use the computer to analyze each cell in the picture, no matter how the file looks like. You look at the file. All right. They probably follow the same format on the probability of each pixel and each cell. Right. What's the color pattern on that? So you basically want a computer to recognize what number it is. All right. Now, talk about this size. I would like to say for this size, one picture, this probably like, let me see. You have saved the picture in the computer, right? So it could be like a 2 or 3 or even hundreds or even thousands of megabytes, something like that. When I say megabytes, that's you can see this how the picture size it is. All right. All right, so this is the picture. Now, think about it. We talked about the video before. So if you look at the 1 minute video, that means millions, the pictures that connect together, each pictures will be analyzed in this way. So that's why I say that's the big data. All right, you already analyze the video is much more difficult than analyze text. All right, analyze text. Now, the question is that if you talk about the Python R, I would like to say Python to some extent will be more specialized in this kind of things. All right, that's truly a big data what I'm talking about here. All right, so this is beyond scope a little bit. Let's go back to our class. I just want to talk about the big picture here. All right, and but of course, if you're interested in some fancy software, you can talk with me because I'm big fans in this field. All right, and let's go back to the R here. All right, so there's only okay, sure, no problem. We can chat more on that. There is a, oh, by the way, the most key important things I forgot to mention here. So I'm so sorry, I bragged too much things here. Now let's talk about the relationship between the cores, right? Of course, this is very beginner in this field, right? If you talk about the data science, right? Like let's say the AI, all right, or sorry, bad color. The AI, data science, all right, and the machine learning and deep learning, for example. If I talk about these things with the software, all right, either R or Python, let's talk about relationship, all right, the thing that I want to say, if you work in these directions, either professional or either academic, most likely the thing most important, you need to understand the algorithm, you need to understand the theory. All right. Although in the oral course, we will not emphasize too much theory. You can see I always reduce the theory to a very minimal level. And but you need to understand what's happened there. All right. You need to understand. I think that's probably the most important thing. You need to understand the theories. All right. Or most likely, when you transfer the theory to computer, you need to probably understand the algorithm. All right. Or some idea, like I say, idea. Or sometimes an idea, some machine learning idea is very straightforward. It's not so hard in terms of intuition, but it's hard in transfer them to the mathematics. Like I said, every people understand picture, every people understand how the 5 is written, every people understand how to look the video. But the question that when you convert that to the to the data in the computer, they're totally different things. So that's what I'm saying here. You need to understand the theory and algorithm or idea or intuition. That's most likely an important thing. And then after you're familiar with this, you select which software you want to use to solve the problem. And of course, in the class for demonstration, we definitely want to use the R because it's easier to demonstrate. But what I'm saying that most likely when people ask you, when people interview you, when people talk about you, they will start with to discuss what you learn here, right? What's the idea behind this? What's the methodology? What's the specialty? All right. So that's probably most nice. What's the difference between these two software? What's the specialty which is? So that means you want to understand very basic foundation behind this idea, and then you talk about which software you want to use. All right. And okay, so now let's talk about the go back to. We still have a little bit here, right, for the lab 2 here, and let's look at this code here, and then we'll just generate results. I think this is pretty straightforward. Again, so DEF data 2, this is what we generate here. All right, we generate here. This here data is beautiful because we drop the index. Remember that what is index? Index is that when you read into the data, we have a column. The first column, I think, the index, which is basically the order of each observation, people 1, people 2, people 3. But actually, this is useless because we already have embedded index in the R, right? It's not in the first column, but it probably in the column 0, right at the beginning. Show the order, so you don't need that. Let's run this first. All right, so I just need the data I want, DEF data 2. All right, so look at it here. So look at the original data. The original data, we have an index here, right? So we don't need that because these are mostly exactly the same as the embedded, the index here for the R environment and data 2. And so we basically already dropped the index, right? We drop here. So in that case, we have we only have a start with the employee as the first variable. All right, so that's the things, and this index will be automatically assigned. All right, so this is the here. All right, and we want to summarize mean S equals mean annual salary divided by 12. So what exactly means here? I want to look into the monthly income, right? That means I use the annual salary divided by 12. That means for each observation, that I can say each household or each person, I want to calculate the monthly income, all right, divided by 12. And I want to calculate the mean, all of them, and summarize and assign the calculated value to the variable so-called the mean, MS. And let's see what happens here. All right, so to give a single value. That's no wonder because this mean basically sum all of the income value and divided by total number of observation. Of course, they're only single value. So that means we were basically doing this. Yeah, this one, we basically calculate the average, the mean value of this single column. All right, and also we divide by 12 for each of them because those are annual income. All right. And you can have a better idea to see what happens here. All right, so we get 3,300, 516. Oh, that definitely is a very big number, right? Probably most, some famous people, whatever. And so we have now the other thing that let's talk about another function so-called a group by. All right. Now sometimes we understand that if it is the information is really not so much information if you just give me only one number about mean salary or whatever average, right? You want to group them. For example, I want to look into if the mean salary has impact on default observation. All right, so that means I need to summarize a little bit for the default people, what's their income. For the non-default people, what's their income? And then I will see, okay, income maybe have some factors. All right, that's probably very straightforward to look into the data analysis at the first step. All right, for example, let's talk about the intuition here. I know, for example, I want to look into the income. All right, the income and relationship between the default or not. All right. Now you have many ways to do this. Most likely, if you're familiar with the statistic, you probably want to do some regression, right? There's default against income. However, this regression we have not touched so far because this regression is very special. This regression default is a binary, default or not. It's not a continuous number like 5, 3, 5.1, 3.2, something like that. So default is actually a binary, but the income is continuous numerical. It could be any number. So this regression will be a little bit special. I will talk about later on. But the question that without any, regression, if you really want to use income to default visually, you can do these things. All right, I basically can summarize default and non-default. All right, non-default, and I can check what is their salaries. All right, salary. All right, so for default people's salary, probably, for example, I say 1,000. And for non-default, I'll say 2,000. All right. So in this, I probably can draw a very initial conclusion and say, okay, I would say the salary has very big impact on the default decision because I say this is twice of them. That's okay. All right. Now, this is always the first step, right? We just look by naked eyes to judge our decision, and then we can nextly we can do some regression to get some really precision relationship, precise relationship among them. Now, but there's sometimes they're maybe tricky. Now let's say here, let's change the number. Let's say after the observation calculation for the non-default people, my calculation is $1,080, and the default people is 1,000. So my question here, how do you say? Do you think the salary has impact on default decisions? You probably say, okay, not much, or even nothing. But the question, to what extent you think 1,000 and the 1,018 they're equivalent? So in that case, we probably need to do some statistical analysis. Remember, we have learned T statistics to judge if mu1 equals mu2 or not. This is not hypothesis. All right, but we will touch later on. Don't worry about this. So far, we have not used this method. I just might want to mention the big picture here. All right, so this is a first step. You want to do some very initial analysis of the data here. All right. So many of them you don't need a very deep mathematics, just intuition. All right. Now let's go here. So in this case, group by, that means we need to use the now remember here. This one is still use, we still under tidyverse packages environment. Actually, we have a library here. All right, you have library here. That means all the environment way in the tidyverse. That means you can safely use the pipe operations. All right, for example, arrange based on the data, you want to group by default or not, and then you summarize mean value, bank balance, for example. All right, so let's do this one. All right, so you can say now. So there is a not default mean bank balance is 9,000 for default bank balance 20,000. That's very interesting. All right, so it's like the default people have even much higher the bank balance. All right, well, you can research a little bit more on that if you have even a job in your academic job, academic work, right? So, but it will be very interesting. We need to dig more into that. All right. Okay, so this is the one thing, right? Group it more, clearly here. And the most important thing I want to introduce here, this is a table. You probably have seen that. And this table is really interesting. It's not like it does not look like a data frame. Data frame is here. It's not data frame, but they have a index 1, 2. They have a FCT. All right, they have a DBR or something like that. So I want to say this is a table. All right, this is a table. Table is what? You can think about right now exactly equals to data frame. Data frame. They're same thing. They're same thing. They have rows, they have columns. All right, you can use the table function to generate a table. Basically, data frame. They are same thing. All right, I mean, they are exactly the same. All right, so far I just want to mention that. All right. So, the thing is here, you can use the table functions generate the data frame by your own self, but I have not introduced right now, right? I just talk about in the future. And you can basically, you're probably wondering what happens here. Why I use the group by, why I use the summarize, give me this kind of a table format data frame here. I would like this is automatically generated by the software. That means when you use group by, when you use summarize or summarize or other functions, basically you want to group by from a data frame, they will give you automatically this format, generate results. They will not show here. Generate new, no. They will generate here. All right. Because remember, when you do these operations, you didn't generate any new data frame. You didn't. You just work on the previous ones. All right, and show the results. That's it. Although the results will be shown in the data frame format. All right. Here you will have a data frame only because you establish a new one, new name. You give a new name, then it will be shown here. All right. For example, if I assign, let's say, DEF new, and I put a assignment, this label here. Now you can see what show here. For example, let's run this. See, it will be show here. All right, it show here. All right, so this is only because you've generated a new one. Okay. Now the last one. Now, sometimes you want looking into the covariant relationship. All right, so you'll probably want to look into that. We not only want to know what is the mean bank balance for the default or non-default, we also want to understand for employee. All right, so sometimes, the bank balance probably will interact with employee or not on the default. All right, now, for example, for employed people, we have a large bank balance. We have a steady income. We have a large bank balance. Do you think we will default? It's unlikely because you have income. I definitely will care more about the job and credibilities, and definitely if I have a surplus money, I need to pay them instead of leave there in the account. But if I am unemployed, I have a bank balance, that sometimes the reason could be very weird. All right, so let's try this out. Let's basically dig more on that. All right, so let's look here. Now you can see what will happen here. Now we have for the, let's say, look at the default, right? It's more interesting. For the default people, if they have a non-employed, $22,000. For default people, employed, $20,000. Okay, it's okay. It seems that if you default either non-employed or employed, bank balance has no impact on that. All right, but for non-default people, if you are not employed, you have a higher bank balance. If you're employed, you have a very low balance. So it looks like your bank balance really, no matter if you're employed or not, really has negative with your default. That means that sometimes you have a higher bank balance, you probably have a higher default, something like that. All right. So I like to say it probably not further explain or dilemma or puzzle here, but they give you more idea on the more dimensional distribution here. All right, and if we have time, we will dig more in and find out what the reason. All right, most likely, if you have such a project, you probably need to encounter such a problem. Please give me a reason. Use the data analysis, either visualization, either regression, or either observation. Find out. So that would be very interesting in the project there. All right. Okay, so that's for the laboratory 2.r file, and definitely you want to go back to the textbook. Probably textbook have a more explanation on this part if you're interested, right? By the way, they have a written notation for those kind of things, and they introduce the question background that maybe have a richer information. Although I discussed them in the orally speaking here. All right. So I give you 1 minute to see if any big pictures here in the questions. Okay, so if you don't have so far, I just want to talk about a few minutes. So in that case, we can end up a little bit earlier on the 12 o'clock. All right, so give a couple of minutes. I will probably have no time to go through all the labs right here, but I will give you a hint on them. So in that case, you can self-learn by your own self. Firstly, with that textbook and on the lab 3 chapters and with my code, you can run. You can self-learning by your own self. All right, and next Friday, we're gonna summarize a little bit more and see if any questions on there. All right, so let me talk about the picture. What's the lab 3 talk about? So in the lab script, we have some key functions you want to be pay attention to. One thing is that, firstly, we continue to use the tidyverse. We continue to use the default thing, the data CSV data there. All right, and we'll continue to factor them. All right, convert them. This is very similar to the lab 2. That's fine. However, our biggest question is ggplot2 library. This is probably the most important function in our software and very popular in the industry. And I strongly recommend you to dig more by your own self and here. And there's many materials. All right. And let me give you a sample in the next. So learn this data visualization methodologies, and they will be very popular. All right. And it can enrich your syllabus. Sorry, the resume. All right. So the ggplot2, you basically learn phrases like this. I'm not sure if the homework, the textbook have dedicated chapter about ggplot2, but you can have many ways to learn that. All right, for example, when I search in Google here, right, you probably the ggplot. All right, the ggplot to ggplot, they're actually similar, but in the recent newest version, they are changed to ggplot2, functions there. All right, and it's in ggplot2. So there's many ways. So you can say ggplot2 by itself belongs to tidyverse packages group. All right, and sometimes you can open that. All right, but I don't say. So you can say by itself, it's introduced a lot. Right, example, so you can follow your own stuff. But sometimes maybe it's a little bit technical for you. You want to look at from very beginner. This packages, you don't need to look into that because this package is simply to talk about the raw data behind this. This is totally irrelevant to you. You don't care about this. But you want to talk about some R document, this one. All right, for example, this one you're really to introduce the basic structure of the software. And again, so it might be a little bit difficult for you to self-learning because this is a little bit technical here, but I would like to say something is pretty good. All right, say like for example, welcome ggplot2 online version work in progress 3rd edition ggplot2. Right, this one is a pretty online good books. Look into that. All right, this is online. Oh, that's very good. I just found that ggplot elegant graph for data analysis. Yeah, this book even for free. Let's see, introduction. Yeah, I think I should include it in the classroom. But anyway, so this book is definitely a 100% dedication to these packages, right? I strongly recommend you to go through this because I just found this very interesting. You can go through introduction, first step, all right, like this, all right, something like that, all right. Now, for example, like I give you. Look at this here. All right. So I randomly look in that library ggplot2. Now you don't need to write here probably because we already elaborated tidyverse because ggplot2 by itself is one of the tidyverse group. But you also can use simply just elaborate ggplot2. You just either way okay. All right. And let me make some note here. You can use the library tidyverse. You can do that. All right, tidyverse have this, but remember you need to install them. If you don't have you probably need to install ggplot2. You probably install tidyverse. All right, if you already install tidyverse, you don't need to install ggplot2 because they have already included this. All right, and so for example, this one simply want to plot. Here, MPG, this one is a kind of a built-in data frame. Now, in the R environment, there's several popular data frame already built in. For example, there is like a world population, like a second car dealership price, or some very popular price, in the data in the society, in every field, in every subject. There's some data there, right? So they use the MPG, and this present the show the data here, and then again, so next they're gonna plot them, use the ggplot to the functions there. So I think the very good book to look into that by yourself. All right, so right, I think it's very good. It's a very good. I want to download the book. All right, and to look into that so you can see. All right, so it's here, right? Welcome to ggplot2 when you search ggplot2 here. So there's many materials you go down, you look into for beginners. So just to look into that, and as your self-learning process, right? Just a few chapters, and then you can go back to our code here. Go back to our code here, and I'm gonna use the ggplot, all right, to plot something. All right, we want to visualize the relationship between the salary and the bankruptcy and the employment, their interrelationship, and then we can probably draw some conclusions there. All right, so so this is basically our next week. You're probably gonna do firstly by your own self, and we're gonna talk about it in the Friday. Okay, that's our for today's class. And if you don't have any questions, you can leave the Zoom room. Thank you.
Professor,
Yes.
I had a quick question about the homework that was due last night.
Yeah.
Basically, I submitted the wrong submission. Like, I made a couple mistakes on the homework, and later on I realized it and I resubmitted it. Well, did you get the right file? Could you please check you got the right file?
Sure. I'll contact you if I have any problem. I will check that.
Okay, thank you, sir.
No problem.
Have a good day.
You too.